So at its heart, object-oriented programming is really just a way of, it's kind of what it sounds like, a way of encapsulating parts of your program as in objects and being able to kind of pass them around the program as units of functionality. And we're going to talk a little bit about more towards classes. So if you happen to have programmed in another language, you may have seen classes. So we'll be talking about that, and this is a way to create instances of things so that you don't have to hand code everything. And then I'll give a short lecture on modularity later this week, and that's going to talk a little bit more about how to create modules inside of your program that have functions built into them. Cool. So let's get started. I'm going to create an object called my house and an object called your house. They're very similar. Really, the only difference starting out is the colors. My house is red and your house is blue. Now you'll notice that they both have a function called paint that does the same thing. So one kind of shortcut we can take is that we could just make paint an external function that we abstracted away from the object, and then we could just set each of the house's keys equal to the paint function. Now, if I say your house dot paint green, and then I console log out your house dot color, oh, 1 second. Hoisting. Always got to keep in mind hoisting. Green. Cool. So you'll see that the method works just as you would expect by pointing back to this original function. One thing that should be noted about this is that when you do it like this, both of these references to the function paint are pointing back to the same function in memory. So if I later on, let's see, what do I want to do? I'll change the function paint to console log out. Console log out, nope. If I call paint, I'm going to console log nope. If I call your house dot paint, it's still going to do what it originally did because they pointed to paint and then they pointed to this function in memory. Now, sometimes when we're going to create multiple instances, or we'll be repeatedly creating instances of something in a program, it can be useful to build a function that will wrap it in the functionality that we want to give it. So this is called the decorator pattern. It's when we pass an object into a function so that that function can wrap it in some kind of functionality. So I'll grab our houses back. And this time I'm going to get rid of the paint function altogether so that we just have some plain houses. They don't do a whole lot. But then I'm going to create this function called hire painter. Hire painter is going to decorate them with that functionality of the painting function. So now hire a painter on each of them, and now they each have a paint method. So you'll see when I console log on line 24, it console logs a function, and I can, as we expect, call my house.paint. And it will alter the color of my house. Cool. So that's the decorator pattern. Before I move on to the next pattern that I talk about, does anyone have any questions about how that works? Alrighty. So the next pattern that I'm going to talk about is called the factory pattern. So when we use a function to instantiate new objects of a certain type. So let's say that we have a function called house. We're going to use this to create new houses. This is going to be our house factory. And what the house function does is, oh, 1 second. I think I lost part of my. All right, so we're going to build this kind of from the ground up. The house factory creates an object inside of itself, creates the house, it builds the house, it adds on all the properties and the method, and then at the end, it returns the house. So now we can say var my house equals red, and var your house equals house blue. Now console log out my house after this. Oh, oops. Cool. So you'll see that we've constructed a house using this factory function. You may notice that I capitalized house. It's often customary when you have, we haven't actually gotten to classes yet. This wouldn't be necessarily considered a class. But when you do have a class or you have some kind of function that's building, that you use to build other versions of that same object to instantiate new instances, you often will capitalize the original to indicate that this is kind of the top level of the original thing. Are there any other questions about that, about the factory pattern, before I move on? Forgot an E on line 7. Oh, I think that was from earlier. Thank you everyone for correcting me. I had the chat hidden. Had I seen your messages beforehand, I could have avoided an embarrassing error. All right, so I am going to continue moving forward. Now, in JavaScript, when I'm talking about that top level object, that original house from which my other houses derive, we're talking about what's called a prototype. And really every data type that you create is connected to some other data type. So, for instance, when I create I'm coming to the console because the browser console, because it's going to be a little bit more transparent as to what's going on. So when I create an array, and then that array has certain methods attached to it, like pop and push, the reason that it has access to those is because it's connected to an array prototype. So there is this prototype of an array that when we create a new array, range inherits everything from that prototype. So what actually happens when we call range.pop, range itself doesn't have pop, the method pop inside of it. It goes looking for pop and it can't find pop. Let's actually demonstrate this. Let's say range.hasOwnProperty, and we'll ask it for a property called pop. False. It doesn't have that property, and yet for some reason we're able to use that property because it exists on the array prototype. So when the interpreter goes to look for range.pop and doesn't find it on range, it falls back up to the prototype. So we'll notice that array.prototype does have the property push on itself. I'm going to console log out array prototype so we can get a closer look inside of it. Might be too big. Okay, no, we can see it. Awesome. It's huge. It has tons of things going on inside of it. Look, all of our old familiar methods, slice, shift, pop. You'll notice some of our utility functions, map, filter, for each. There's some that we haven't used before. Cool. So these exist on a prototype somewhere. And it's the same for everything that we have. We have a string.prototype. It has our string functions on there. I actually need to look into these. There are a few that I have not used before. You know what? I want to see, what does this string.big do? It's a function. It doesn't take arguments. So I'm going to make a string. That's interesting. I think it created an HTML element of that would be big if it would be larger than regular if we posted it to the page. So that's an interesting method. In any case, these prototypes of each of our data types holds all the methods that we usually use to work with. Now, we can create our own prototypes. When we want to build our own objects that are inheriting properties similarly in our programs. There's different ways of instantiating objects, different patterns. This factory pattern is known as the functional pattern for inheritance. The one that I'm about to display is called the Pseudo classical pattern because it looks similar to how classes behave in other programming languages. Now in JavaScript, prior to ES6, there were not actually classes. Actually, and even with ES6, there are not. There are syntactical conveniences that come with ES6 that make JavaScript appear like it's creating classes, but it's still actually just using that prototypal inheritance. It's using the prototypes to inherit things. It's not creating classes in the same way that other programming languages do. So this is what the pseudo-classical will look like. We're actually going to create an object called house that's going to act like our original house. Now, this original house, this is actually our constructor function. And we're still using it to create new houses. Our house prototype exists separately. So it's important to note that this function, its prototype is not the house prototype. This is going to have the function prototype because it's a function. The house prototype is something that we will create separately. I'm going to copy and paste my methods over again so I don't have to type them. So we are now adding things to this house prototype that we are creating. It wasn't existing there before. There's not some kind of magic that we've worked to create this prototype. It's just a normal object that we're creating and adding things to. However, what is magic, interpreter magic, when we want to create a new house, we can say var new house red, or my house. So we'll say my house is equal to a new instance of this class house red, and it's going to call the constructor function. And then I can console log out my house. Cool. And we'll see that just as we expect, my house contains a color and a door. These methods, again, they exist on the house prototype. So if we say my house.has own property to check if those methods exist on my house, we'll see a false. They do not exist on my house. They exist on the house prototype. However, because my house has inherited a pointer to this prototype, when we try to call my house, let's see, I'm going to comment those out just so that we can have a clearer console when we do this. When we console log out my house.color, it's going to give us red, but then I can call my house.paint and pass it green. It looks on my house for that paint method. It doesn't find it, so it falls back up to the house prototype. So now when I console log my house.color, it's changed to green. I will copy and paste a link into Slack, which covers this pseudo-classical method because it's actually not covered in the curriculum. So it covers the pseudo-classical and the functional. You'll notice that there are some other types on the link that some other patterns for inheritance on the link that I'm going to copy and paste into there. I'm not going to go into those. This is actually a larger area, something that would cover more than a day, that could possibly cover a few days. And I don't want to go too far into it because it's something that you'll go into more extensively in the immersive programs if you go into them. And I think it won't be helpful for now. But I just wanted to kind of give you an overview of what classes and prototypes and this reference to object-oriented programming in JavaScript looked like. So are there any questions about either this pseudo-classical pattern or anything that I've covered in the lecture? Should I take this lack of questions as a sign that you totally understand everything about object-oriented programming and prototypes and classes in JavaScript now? Or should I take it as a sign that there is perhaps some confusion and maybe you just don't know what questions you want to ask yet? Okay, that's cool. Thank you, Kevin. That's fine. I'm going to go ahead and let you go and break into pairs. Yeah, I think once you start to work through the exercises, it will start to make a little bit more sense. But I'll have some review or answer any questions that come up tomorrow morning, maybe before we start in on projects. I can answer whatever questions come up. I know that this is kind of a turn in a different direction than we've been working, and this is a different paradigm for programming. We've been focused for the past week mainly on what's called functional programming. Now we're looking at this whole other big area. So don't worry if it seems a little bit fuzzy. Just work through the exercises and feel free to ask any questions that you need to ask like you usually would. So yeah, without further ado, I will stop the screen share and I will